Hello, this is Derek. This is section 9.4, and this is the quadratic formula. So, the quadratic formula is, if we have a quadratic of the form ax squared plus bx plus c, and we very carefully solved that for x, and it would take me about half a page to do so, we would get this formula. And so basically what this is saying, every time I have something of this form, if I know those coefficients, I can plug them in here, and it will get me the solutions to the quadratic. So that said, if I have something simple like x squared plus 3x plus 2 equals 0, I would not want to go through the trouble of grinding all of this out, putting in, 1 for A and 3 for B and 2 for C, when I could look at this and say, oh, x, what multiplies to 2 and adds to be 3 would be 1 and 2. And then my zeros are going to be -1 and -2. Factoring is still much easier if it's available to us, but it doesn't always work. Sometimes things do not factor, and that's where we have the quadratic formula. So this little piece, we won't look at this a whole lot, but this piece under the radical is called the discriminant. Depending on the sign of the discriminant, a quadratic can have 3 possible outcomes when solved, and I kind of referenced these in the last section as well. If d is less than 0, if I get a negative under here, so there's no real solution to this, that's telling me that my parabola doesn't have x-intercepts. If this comes out 0, then that reduces to negative b over 2a. That's the vertex formula that we saw from the last section, and that's exactly what that's giving me, is the x-coordinate of the vertex. And that there's only one x-intercept, and it's doing that bouncing behavior. Or kind of the normal thing that happens is this is a positive, and then we end up with 2 intercepts for our quadratic. So, okay, so for this first one, I want to get this in standard form, so I'm going to bring everything to one side so it equals 0. So that would give me 3x squared minus 4x minus 2 equals 0. So then my a equals 3, b equals -4, and c equals -2. And then I'm just going to put those into the quadratic and kind of grind all that out. So x equals, it goes negative b, so it's going to be the negative of -4. You're welcome to just write +4 there, but I'm just kind of showing all my steps. And then b squared, careful right there to get -b quantity squared. If you write down -4 squared and throw that in your calculator, that comes out -16. This should be +16 because you're going -4 times -4. So b squared and then -4, a is 3, c is -2, all over 2a, and a was 3. And then from here, it's just really a matter of simplifying it, which is sometimes easier said than done. So -4 makes 4 plus or minus, that would be 16. Double negative, I just count the signs. So if there's 1 negative, I'm subtracting 2 negatives, it's going to be a plus. 3 negatives, it's a minus, right? And then 12 times 2 would be 24 over 6. And that makes 4 plus or minus 30, 40. Over 6, and then that is x equals 4 plus or minus 40 is 4 times 10. It's lots of things, but I am picking 4 times 10 because 4 is my perfect square. So then I can take square root of 4, that comes out of 2 root 10 over 6. And then the last thing to do is to reduce this fraction. So here's the way to look at, well, let me do the factoring version first. If you can factor the same thing out of the numerator and denominator, that means it cancels. So let me show you that, and I'll show you the easier way to think about it. In this case, I can factor a 2 out of the numerator, so that would be 2 plus or minus root 10. And 6, I can factor that to 2 times 3, and that allows me to cancel. So that's why this next thing works. So what an easier way to look at it is, if there's something you could divide into everything, do that. And you look at it, you go 4, 2, and 6, everything's divisible by 2. So 2 goes into 4 twice. 2 goes into 2 root 10. The 2's would cancel, leaving just the root 10. And 2 goes into 6 3 times. So I get the same thing. It just, I think it's a little bit cleaner to do that way. And then for entering that in the computer, it's terrible, but what you get to do, I think, for most of them, is you put it the same way if the answers had been, 3 and negative 4, you would write 3 comma negative 4. Here you're going to write 2 plus root 10 over 3 comma 2 minus root 10 over 3, because those are literally, that's like your 3 and your negative 4. Those are your two solutions. Okay, so decimals are not going to make this better. So what we're going to do is multiply both sides by 100 and just get rid of the decimals, and then it'll be a way easier problem. So now that becomes, I'm doing 100 right because I have to move my decimal 2 places. So now this is 2x squared, that is plus 5x, and that is plus 1. And that's much easier numbers to work with. So x equals negative 5 plus or minus 5 squared minus 4 times a times c all over 2a. So 2 times 2. So x equals negative 5 plus or minus 25 minus 8 over 4. And 25 minus 8 is 17, which is awesome because 17 doesn't reduce, and so that means we're done. That's it. So our solutions would be the negative 5 plus root 17 over 4, and then comma, same thing, negative 5 minus root 17 over 4. Okay, so fractions also don't make things better. So let's get rid of those. And I'm going to, same idea as the last one. This time I'll use the LCD. So I got 3s and 4s. So I'm going to multiply every term by 12. Unfortunately, I have to multiply that y as well, which is right where people forget. So 12 over 3 would make a 4y squared. 12 times y will make a 12y. And then 4 goes into 12 3 times. And right now that's over on this side. I'm going to bring it over and write it as minus 3 and then equals 0, just to have that set up. And then this one does a bit of reducing. So here we go. We got y equals this time negative 12 plus or minus 12 squared minus 4 times a times c all over 2a, so 2 times 4. And then that's going to get us negative 12 plus or minus, that is 144, 2 negatives, so plus, let's see, 48 over 8, that makes 192. And then 192 is not the easiest number to break down. It ends up being 64 and 3. So 64 is the largest perfect square in there. And I think I actually hit, I maybe hit 16 first and then saw the 48 left and went, there was still more I could do. So, you know, you may have to look at it a little bit to find the right number. Anyhow, reducing that, I'm going to get y equals negative 12 plus or minus square root 64 would bring out an 8. 3 stays inside over 8. And then if we look, we don't need to reduce this. Think of that as being like an x. But for all the coefficients, the largest thing that divides into all of them is 4. So even though we could do 2 into everything, we want to reduce the most we can. So the same way if this was like negative 12 eighths, I wouldn't want to reduce that to 6/4. I'd want to reduce it to 3 halves. So here we're going to divide everything by 4. 4 goes into here, negative 3 times, plus or minus 4 goes into 8. 2 root 3 stays the same, and then 4 goes into 8, 2. So that would be my 2 solutions. Okay, and then this last one, on the homework, I think it has you solve both to the simplified form like I've been doing, and then also round to the hundredths, just to get some practice putting this in the calculator. So this would go x equals negative of negative 2 plus or minus negative 2 quantity squared minus 4 times a is 1, invisible 1 in front of the x squared, and c is negative 11, all over 2a. So that is x equals 2 plus or minus 4 minus or minus, so plus 44 over 2, which is 2 plus or minus root 48 over 2. And 48 is a 16 times a 3. So that would be x equals 2 plus or minus 4 root 3 over 2. And then this one, it divides in all the way. So 2 goes into 2. If I cancel that out, it'd be once plus or minus 2 goes into 4, 2 root 3. So that would be my two solutions. So the first one is 1 plus 2 root 3, and the second one is 1 minus 2 root 3. And then putting those into a calculator and rounding to the hundredths, so two places, I got 4.46, negative 2.46 for that one.